Hello everyone, thanks for sticking up during the coffee break. Hopefully you got caffeinated enough before. So we do different things. So my name is Yamshchikov. I'm doing a postdoc for AI and cognition back in Germany in Max Planck Institute. And I'm interested in different aspects of generative AI. And we had several projects within the startup that we also do, created labs, with my co-author, Alexey Tikhonov. So it's like basically created with AI in the middle. And we do different applications of generative models. So for example, the ones that we featured and wanted to feature was the lyrics generation model, when we generated lyrics for a short music LP and we recorded it, and this is the example. So can we have...
It's you to mass. This is a game of hard abuse.
There will be some... Sorry, this is Kurt Cobain lyrics. So last year, Kurt Cobain would have been 50, and for that we actually generated lyrics and recorded an LP of 4 songs. So the text here is generated, the music is performed by an actual musician. And yeah.
So those lyrics are generated from a recurrent neural network.
Yeah, exactly.
That's awesome.
We have several papers on stylized text generation. One of them I present there. One will be published on SLT later this year. This is variational autoencoder that is trained on a huge data set of text, and we try to generate lyrics that resemble some poems of actual authors. So as an example that I show there, for example, there is an example of Edgar Allan Poe where it says something like, I think it's not featured, but I remember it really well. There was an example. The rose she saw was beauty shining, a flower full of gold, of silence and a warning that nothing told. This is another example of generative Poe that we had. Yeah.
Nice.
Yeah, thank you. And we also do some music generation as well. So back there on the stand, later, if you have time, you can come over. I can show you that the model itself is so simple that when trained, you can actually fit it onto Raspberry Pi. So it's really small.
Wait, so you're saying that you can fit your recurrent neural network that's a music generator onto Raspberry Pi. How much memory does that require?
Well, the network itself is like 4-layer LSTM, and all the memory that Raspberry Pi 3 can give me, we use it.
Nice.
But you just need to be able to install TensorFlow on it, and hopefully the SD card can do the rest for you. So these are examples of music generation that's already orchestrated. So basically, we don't use a generic sample. We play with samples a bit, and we added some generative beat. So the melody here is generated, but the drums are just sampled. Yeah, and there we have the Raspberry Pi where it just plays live without self-repetition. The problem with all the generative models now is that they give you a lot of rubbish. So a lot of the things that generate don't sound too good to you, and then you don't know what to do. And a lot of people get discouraged, and they're like, oh, what should I do? AI cannot generate things, and they quit. So we didn't do that. Instead, we just came up with some easy way to filter what we generate. Because we don't care for accuracy. We don't care for recall. We just need accuracy. We can throw away 99 tracks out of 100 as long as the one track that we finally get is actually good. So for that, we just labeled humanly the generative input, with 80% of it being assessed by people like as bad one, and then trained a separate classifier for it. So, and then the classifier filters the stuff that's bad, and hopefully then it allows us to have the model that generates something that's acoustically pleasing on the go, on the flight.
I mean, that sounds a lot like how music can be made in general. You know, you might work and try out tons of different things, but you find the one thing that works, and then you go with that. You take that on the road.
Exactly. And I have another example of music generation. So this is an example of collaboration with... So this is the video that was recorded during the opening of the tech conference in Moscow. So here, this is severe cherry picking of our model done by a professional composer. So we took a modern composer and worked together with her. Her name is Maria Chernova. And the guy who's playing theremin on the video is actually great-grandson of Leo Theremin, the inventor of the instrument. So this is one of the first analog synthesizers. It was invented in Petrograd in 1922. And this is the great-grandson who's now playing the great-grandson of the inventor. Yeah, so melody here is also generated by the neural network. It was trying to imitate Scrabble style, and the composition is done by professional composers. So of course, AI is an awesome tool to fight writer's block. Because like AI gives you a possibility to basically interact with your topical area and just gives you some random impulse that can move you in the direction that you would like to be moved further. So it's also a very interesting application of that.
This is really cool. It ties in nicely to our early Q&A this morning about generating synthetic art with artificial intelligence.
Yeah, we got in touch, and we want to make an art project together now.
And here it seems that almost you're generating music, but also then humans are performing it as well. And so it sort of almost closes the full loop there. It's really cool.
Yeah, well, at some point the robots should start performing it, and then we're done. And the robots will also listen to it. Then it's like, then it's the full circle, but we're not yet there yet. But I mean, yeah, that's eventually something that we would like to do some more automated performance. The good thing about these generative things is also, so we like variational autoencoder architecture because it's got the latent representation of the variables, and you can pass some interactivity to it really easy. So it doesn't have to be only standalone end-to-end model that learns something. It could have some feedback. So for example, if somebody here is doing medical data and research brain wavelengths, I would love to have a brain signals as the reinforcement input for generative music, right? How cool is that? Like have a model that wakes me up by music really well and in a mild way, or have the music that actually helps me to soothe down to sleep. And you know, there are a lot of possible applications. The general point that I would like to, I mean, we don't have a lot of time, but I'm really enthusiastic about the fact that AI, despite the fact that it generates a lot of bullshit, sorry for that, it's actually workable. You can still do amazing things with it. So I really would like to encourage people to look more into generative models of the state of the art, because despite the fact that you can get some bad outputs, you can find workarounds.
This is really cool. Yeah. Have you considered open sourcing some of the tools you've used to generate this music and other poetry so that other people can
currently
can build on it?
I'm full-time in academia, so we can open source only after we get published. But we're working on that as long as we, I think by the beginning of 2019, we'll open source the music generation part.
That's awesome. Have you followed some of the work that like Douglas Eck and others have been doing at Google Magenta with I feel like they've been training models on measure-based approaches as well. So what do you think of their work?
It's amazing. I love it. Actually, we did music not because we wanted to do music, frankly. We did music because music state space has lower dimensionality than text state space. We wanted to do NLP, but with natural language dimensions, it gets crazy. You get this dimensionality curse, everything blows up. It's hard to train the models. It's even harder to understand which representation makes sense in terms of dimensionality, and the space, the state space of over which you try to learn something is actually very sparse. So there were a lot of technical problems and issues, and we thought, okay, music is less. One would say that if you generate music note by note, then it would be less diverse than text, because you have note, octave, length of the note, and length of the pause after it, and that's about it. And so our idea was, okay, would we be able to just have the smaller dimensional state space and try to test some generative architectures on it so that further use these architectures for the natural language? So the motivation behind that was like, let's test it on music and then move to text, whereas Magenta is mostly focused on music. And so the things that they do is really amazing. They do a lot of they work a lot also on connecting the bars. So if you work with AI, you know that AI is really bad in long context. So AI that we currently have basically behave like fish. They remember last 3 seconds of their lives somehow. Well, in a sense that if you talk with any assistant for like 5 sentences, then it loses the context. And the same happens with generation. It loses the melodical structure at some point. And I think what Magenta does a lot is that they try to generate bar by bar and also connect the bars on the way, which is one of the way to go. So yeah, I think it's interesting.
Cool. So you're saying we haven't quite figured out sonata allegro form yet?
We haven't figured a lot of things. The main thing we didn't figure out is what does it mean to mean something. So with NLP, it's really very clear. So, I mean, we have the information theory. 2 great minds, Kolmogorov and Shannon, came up with it during Cold War because they wanted to decode the messages. And then they assumed that all the information that's in the message is useful information. So they created this information theory, great tool for cryptography and everything. But now we live in the internet era, and like 99% of the information we have is actually irrelevant. But these guys didn't come up with a theory for relevancy of information, let's say. And so effectively extracting this salient part of text out of the NLP or out of the music or out of DNA is actually a huge problem because we don't have a mathematical toolkit for it. And developing it is actually something worth doing. I strongly recommend to focus on it for everybody.
Awesome. So one quick question. As a researcher and a builder of these tools and as an artist when you're creating the output that we've seen here, what's your favorite part of the entire process?
Serendipity. That like you just look through what model wrote and you're like, oh, that's amazing. I give this example when I present this text generation thing. So with Kurt Cobain project, in one of the songs, by the way, you can get it on iTunes if you want. I'll get rich. But with Kurt Cobain, we had this line in one of the songs that says, if you find a tree, you can leave your mark, a God who's always welcome to Iraq. And it's really amazing because Kurt Cobain died before the start of the Iraqi campaign, but you kind of feel that if he was alive, he would write something about Iraq. And so the model learns apparently from other texts of other grunge bands that probably mentioned this geopolitical factor like after his death and samples it into the sentence. So this serendipity that happens when you work with these models and look at the generative output is the most part of the fun for me.
That's really cool. Well, thank you so much for sharing this with us, and it's been a joy having this conversation with you.
Thanks a lot.
Everyone.
And I'm over there. If you have some questions, come over to the stand and let's discuss it a bit more. Thanks.
Thanks.